Hi friends, welcome back to my YouTube channel. In this channel, I am going to discuss the chapters of Maths 1A first year. These are the chapters of Maths 1A. Let us start the second chapter, Mathematical Induction. These are some important definitions of this chapter. First, well ordering principle. Any non-empty set of a positive integer has a least element. Second, principle of finite mathematical induction. Let S be the subset of capital N such that first, 1 belongs to S. Second, for any k belongs to capital N or k belongs to S is equal to k plus 1 belongs to S. Then S is equal to N. Now we will discuss the statements of mathematical induction. First, for each small n belongs to capital N, let S of n be the statement, the given problem. Assume that S of 1 is true. For any k belongs to capital N, if S of k is true, then S of k plus 1 is true. Then S of n is true for all small n belongs to capital N. Now we will discuss the steps to solve the mathematical induction. Step 1. Let S of n be the statement, the given problem. Step 2. Put n is equal to 1 in S of n and prove that LHS is equal to RHS. Therefore, S of 1 is true. Step 3. Put n is equal to k in S of n and assume that S of k is true. Step 4. Put n is equal to k plus 1 in the n term of LHS part of S of n. Then add this term to S of k on both sides to get S of k plus 1. Therefore, S of k plus 1 is true. Step 5. By the principle of finite mathematical induction, S of 1 is true for all small n belongs to capital N. This step is most important and have to be written at the end of every answer. Now we will solve an example of mathematical induction using the steps that we have discussed above. Question. Using the mathematical induction to prove the statement 1 plus 2 plus 3 plus so on up to n is equal to n of n plus 1 by 2 for all small n belongs to capital N. Solution. S of n is equal to 1 plus 2 plus 3 plus so on up to n is equal to n of n plus 1 by 2. According to the step 2, put n is equal to 1 in S of n, we get LHS is equal to RHS. Therefore, S of 1 is true. According to the step 3, put n is equal to k in S of n, we get S of k is equal to 1 plus 2 plus 3 plus so on up to k is equal to k of k plus 1 by 2. Therefore, S of k is true. According to step 4, put n is equal to k plus 1 in the n term of LHS part of S of n. We get n is equal to k plus 1. Now add the above value to S of k on both sides. We get S of k plus 1 is equal to 1 plus 2 plus 3 plus so on up to k plus k plus 1 is equal to k of k plus 1 by 2 plus k plus 1. Now solving the equation, we get S of k plus 1 is true. By the finite principle of mathematical induction, S of 1 is true. Thank you for watching this video. If you like this video, please like, share and subscribe and press on the bell icon for the further notification of our new videos.